Hello there. Today I'm going to present our solution thus far for EY Techathon 6.0. Our problem statement is IT-BPM. Imagine a patient who needs urgent care and checks their insurance provider directly to find the best nearby hospital or specialist. They arrive at the hospital at the right time only to be told that the provider is no longer in their network or the listed specialist does not practice at that location anymore. Now, you might think the situation is not so common, but in fact, the situation is very common and it does lead to people losing their lives at times. So, across the healthcare industry, it has been found that 40 to 60% of provider contact and directory data is inaccurate. Even after manual verification, accuracy barely reaches 60 to 70%, and fully correcting provider data can take up to months. For insurers, this creates compliance risks under regulations like the No Surprise Act. For patients, it leads to delays, unexpected costs, and loss of trust. Some numbers to support them would be a 10-minute delay leads to 9% higher mortality rate, and around $2.4 million are spent annually on data issues. Furthermore, 650,000 plus IDR disputes are filed in 1 year in the United States of America. So the core problem over here is not lack of data. It's that provider data is verified manually, periodically, and across disconnected systems. So now Nexus AI comes into play. So before we dive into the project, let's try to understand the basic architecture of the project. So the project is simple. We are using a Supra-based backend where all the provider credentials are stored, provider validation records are stored, and providers approved directory data is stored, confidence and history score is stored, and AI generated change suggestions are stored. Our insurance person or insurance admin basically logs into our website. Then we basically have a Redis layer for API cache and rate limiting, and we have a Celery task queue which would be used for automatically validating provider data on a weekly basis. Coming to the agentic part of our project, we basically have different agents that perform different tasks. So the first agent is a data validation agent, which would go through an NPI registry API, verify the details that are present, and we would also have our custom web crawling agent within this that would basically crawl through Google, crawl through the internet, and find correct data. Once the data has been validated, we're going to have a base confidence score. After that, we have our information enrichment agent where we're adding state licenses and more details so that our data is more accurate and more enriched. After that, we have our QA agent whose task is simple: get an actual confidence score, verify data from all these websites, and that is pretty much what it does. And then we have a directory management agent which would help in generation of reports and things like that, so that the providers have a clear understanding about the entire process and how well things run. And for now, we're going to have a human review just so that they can actually approve data rather than directly changing things in the database. So that is pretty much the flowchart or simple architecture diagram. Now I'll show a demo. So here's the recording. So it's quite simple. What happens is we're running this on, we're running the Python script directly right now. We haven't integrated the backend. That would be something that we will work on in the future. So it's simple. We basically enter a person's name. We enter their other details such as NPI. We enter their email, practice name, details like that. And our backend starts processing. So for now, what we're doing is we are storing the changes that have to be made in a file rather than directly changing the database, because we want human approval and we also need a confidence score to understand whether we need to change data, and if we need to change data, how much of the data should actually be changed. Now the process continues in the backend. We have all our agents set up, and as you can see, the demo file is created right now. Once the demo file is created, you can see the actual output. So this code is just about to run. And as you can see over here, we get all the details. So both we get idea about the details that have been validated, and we also get extra details. So if we look over here, the web crawler has been able to extract details from various sources. It's stating all the details, and then we also have agentic reasoning, which basically provides us the reasoning of why or how it searched for the required data. So this is pretty much what we have, and these updates would be made into our database, where dark basically means whether it's verified or not, and we have a basic confidence score for now. Let's understand the database. So for now, we use Supra-base. For now, we have used Supra-base. So this is a database that we have. So we have three databases. One would be a provider database having details about the provider. Then we have credentials database. Here the updated credential would be present, and validation database just to keep the store of all the validation tasks that have been performed till now. This is our demo app. We haven't really built it. We have just created a basic demo from our wireframe. So once someone logs in, they see a dashboard like this. They have total providers, pending validations, number of high confidence customers, and need for review. And you can basically export this data and sort this data based off of different factors. And if you dive into one profile, this is what you'd have. You would have a total breakdown of their entire validation process and what data is right and what's not right. And yeah, that is pretty much what our front end is for now. For future scopes, we are planning to integrate a couple of things. So one would be a calling agent. So if our confidence score is low, suppose below 50, we are trying to mimic the human process where they actually call up the industries or call up the providers and actually validate data. So for that, we're going to use Twilio. We're going to have a basic agent for that would call. We would get the transcript and we'd make updates. Another thing that we would like to do is we would like to work on explainable AI part of things, where we are actually explaining why certain changes were made, just so that we have a history of why certain changes were made and we can learn from that. Apart from that, we are working on the XGBoost model for creating proper confidence scores. And last but not least, we would want a geospatial thing or geospatial feature where normal users could basically scroll through Google Maps or scroll through maps in their locality, and they could basically get an easy understanding of what provider data is correct, what is not correct. So yeah, that is pretty much our solution till now. We'd love to gain some guidance from the EY's team, and also we have uploaded everything on the PPT, so you can check the GitHub repo. So thank you so much for tuning in.